Okay, we want to take a look at a couple applications for slope. One very common one is something called the grade of a road, and that's just the slope expressed as a percentage. So a 4% grade would mean that I would go up 4 feet for every 100 feet. So just up a little bit over a very long distance. Okay, let's use that in an example. What if we know that the maximum grade permitted on a highway is 6%? At that, how many feet would we be climbing over a distance of 10 miles? All right, well, we can convert to feet at the last step. We can work with the 10 because it's a nicer number at this moment. All right, so what I know is rise over run, my grade is 6 over 100, 6 per 100, 6%. So I'm going to take that and set up a ratio here. I have the 6 over 100 equal to how much do I rise, how much do I climb, don't know, use an X, over how long of a distance, in this case 10 miles. One easy way to solve a ratio is to cross multiply. So if I do that, I'll get 100x equals 60. Dividing through, we get 0.6 miles. Now, they wanted to know how many feet we would climb, so we use this conversion factor. There are 5,280 feet per every mile. So if I take that number times the number of miles I have, I rise or climb 3,168 feet over those 10 miles. Okay. Another application for slope would be average rate of change. This is some population data, census data for St. Louis, and we have a number from 2000 of 348,194, and in 2010 that had shrank to 319,294. We want to find the average rate of change in population over that period of time. Right, so we're figuring the change in population over time. That kind of gives you a clue as to how to set it up. The other thing that's important to remember is that we always have to go the same direction for both our x's and y's. If I were to write these as ordered pairs, it would be 2,000, 348,194. The other ordered pair would be my 2010 and my 319,294 number. So when I take the difference in the population, 348,000 minus the 319,000 numbers, I have to do the same thing with my time and start with the 2,000 minus the 2010. I have to do that or I'm going to get my signs messed up. Now I notice here that I'm going to get a negative number. That's all right, no big deal. When I simplify this, it tells me I have a negative 2,890. The appropriate label for that was, what was this top number? People or population, so it's people, over years in time. So we're losing 2,890 people per year. That's why that negative is important. It tells me if it's going to be an increase or a decrease change.